Hi everyone, so we're continuing with our work solutions of CSEC Math Paper 2 and we're on January 2025, question number 8, part B, which has to do with the velocity time graphs. So in this velocity time graph, it describes a journey of a car over a period of 70 seconds and the journey is represented in 5 stages that are labeled 1 to 5. So just going to zoom out a little bit so you'll see the entire graph. Alright, so this is the velocity time graph for the car that is traveling in 70 seconds from point A to point B, and it has 5 stages of its journey. So, part 1, complete the following statement. During stage 4, the car is traveling at blank meters per second with an acceleration of blank meters per second squared, and that is with 2 marks. So let's go back up and look at stage 4 of the journey. So stage 4 of the journey is this flat horizontal part of the graph, and of course this means that the car is traveling with a constant velocity, all right, because remember on the y-axis we have velocity plotted. So the velocity remains at a constant, and if we go across to the y-axis, we could read off what that constant velocity is, and therefore this is 45, which is midway between 40 and 50. So of course we know if a body is traveling with constant velocity, then the acceleration is 0, because we know acceleration is change in velocity over time. So if the velocity is a constant and not changing, then therefore the acceleration would be 0. So therefore, during stage 4, the car is traveling at 45 meters per second with an acceleration of 0 meters per second squared. So let's look at part 2. Determine the maximum acceleration of the car during the 70 seconds for 2 marks. So notice they put the word maximum in capital letters. Now, let's look at the stages when the car is accelerating. So, of course, since this is a velocity time graph, we know acceleration is given by the gradient of the graph. So, there are 3 parts, 1, 2, and 3 parts where the car is accelerating or decelerating. Now, of course, the part of the curve, which is part 5, the part of the graph, which is section 5 of the journey, which has a negative gradient, means that the car is decelerating in this part of the journey. So we're not going to look at part 5. We want to find the maximum acceleration. So the parts of the graph where the car is accelerating, where we have a positive gradient, will be stages 1 and 3. So which one of these would give the maximum acceleration? So of course we have to look at the gradient of both of these lines. Now we could tell, actually, just looking at it, which line would give a bigger gradient, which would be steeper. We could clearly see that 3 is the section of the graph, 3, this line, is steeper than 1. But of course we have to show calculations, right? So if from this point on the curve to this point, I keep saying curve, sorry, graph, this point on the graph from 0, 0 to this point here, so let's figure out what the x coordinate is. All right, so if we go down, that will be 15, midway between 10 and 20. So this point here is 15, 20. So it means the car traveled up to 20 meters per second in 15 seconds. So if we do a quick calculation, acceleration we know is change in velocity over change in time, 20 divided by 15. And of course, if we divide that, we would get 1 1/3. So the acceleration for, I'm just going to put here stage 1, is 1 1/3 meters per second squared. So let's calculate the acceleration for stage 3. So if we look at stage 3 now, this point here, all right, will be, this is 25, so this will be 25, 20. And then we have the other point, which will be, this is 35, 35, 45. Okay, so let's look at the change in velocity. So the velocity went from 20 to 45, right? So that's a change of 25. And that change in velocity happened in from 25 to 35 seconds, so that's 10 seconds. So 25 divided by 10 gives 2.5 meters. Well, since we're using fractions, let's use fractions, right? So that's 2.5 meters per second squared. So therefore, the maximum acceleration, we could clearly see that 2.5 is bigger than 1.5. So therefore, the maximum acceleration is 2.5 meters per second squared. So let's move on to the last part, part 3 for 2 marks. Calculate the distance traveled by the car during the first 25 seconds of its journey. So in the first 25 seconds of the journey, all right, of course, we're looking at this point here. So to calculate distance traveled from a speed-time graph, it's the area under the graph. So if we're looking at the area under the graph, we're looking at this shaded part here, which is the area of a trapezium. And we know area of a trapezium is given by a half of A plus B times height, where A and B are the parallel sides of our trapezium, and of course H is the height. So let's determine H first, right? H, which is the height of a trapezium, which will be 20 in this case. A, which is the first parallel side of the trapezium, the top, from 20 to 25, so that will be 10. And B, which will be the base of the trapezium, 0 to 25, right? So that's 25. Okay, so let's substitute all of that. So distance traveled by the car, distance, I'm using S for distance, or, sorry, S is used for displacement. Let's use D. So D, again, a half of A plus B times height. So a half of A was, just go back up, A is 10, B is 25, H is 20. So 10 plus 25 times 20. So it will be a half times 10 and 25, of course, is 35. So it will be a half by 35 by 20. Short way, a half of 20 is 10, and then 10 by 35 is 350. So therefore, the distance traveled by the car during the first 25 seconds of its journey is 350 meters.